Good morning, everyone. Today we will focus on the installation of Docker and also some concepts underneath, which is like using Docker Compose, model stage Docker file, how to create an image, how to create a container from the image that we created earlier, and also pushing the image to Docker Hub and everything. The prerequisites are we need to have Git and also Docker. So we can follow this document on how to install Docker. Currently, I'm on Mac with M1 Pro, which is an Apple Silicon chip. So let's go to this website. Like if you click on this link, it will go here. I already downloaded the Docker Desktop for Mac with Apple Silicon. You can choose Intel. The process is same for Mac. We just once it's downloaded, we just have to double click. It opens this application installation bar, and we just need to drag and drop. Uh, I already have it, so that's fine. Now let's open our Docker. That's it for as this is the first time like you're opening Docker, it's going to verify and also have some permissions if required. We just have to grant permissions. So let's wait for a bit. Let's open. Yep, I already have my Docker installed, so it's not asking me any permissions, but usually you are going to allow. So that's the thing, but if required, the main settings that we have to change is we have to specify the CPU limit. I think I over provisioned this one. Maybe let's do like 4 CPUs and memory is 8, and then let's click. I think like 64 is more than enough, and then we can apply and restart. So that's it's simple to install on Unix devices. Now as a second step, like we also have the steps to install Docker on Ubuntu. I currently have a VM provisioned on GCP. I'm just going to SSH and then I'm going to install Docker on these machines. Let's get connected. Let's get here. Add official GP key. Let's copy this one. We just have to like enter this, and it will just bring all the code. This step is crucial because we are currently going to add Docker official uh, repo uh, into our apt sources. So adding GPT key is must. And then we are going to add the repository here. And then we're just going to update. If you observe clearly in the get 6, it says like Docker previously did not allow on the first step, but it's going to bring from Docker. Now we just have to execute this step. This one, if this one's going to install Docker CE, Docker CLI, containerd, and Docker Compose, build it plugin, and also Docker Compose plugin. We have to keep S here, or Y. We have to enable Docker so that in Linux systems, if you enable Docker or like if you enable any service, it's going to start whenever machine is going to reboot. So that's the part here. So let's continue and so start Docker. Now we're gonna say like Docker hyphen conversion, and it's gonna like I'm gonna say like Docker images. It's gonna throw me an error because permission denied, and we need to have sudo permissions. Uh, image- sudo permissions, but traditionally it is not recommended to use sudo. We have to use anything which is not sudo. So what I'm going to do is like I'm going to create a new Docker user group. That's it. And then what we're going to do is like we just log out and log back in. And then we so let's see if this works. Yep, perfect. It works perfectly fine. Now let's get started. I forgot, like we also need to install Git. That's it. We got Git installed. So first of all, I'm going to create a directory. Java compose. Oh, sorry, I did not create a directory. I'm gonna create a directory. I want a list, and I can see this directory present. So first thing is like I'm going to Uh, yeah, first of all, instead of like going with the front end, I think like front end is dependent on back end. So let's start with back end. So I'm going to first clone this repo, and then I'll be changing my directory to that. And then so here's simple. So we need to have like Docker build hyphen T, and then this is like the image name that you want to specify, like a currently specify like calculator backend, and then this is the tag, which you can also say like version of the image or something like that. And at the end, you need to have this apostrophe which specifies like a full stop which specifies like the location where the Docker file is present. If you if you see here, if I click ls, you can see there's a Docker file here. Let's read what's in Docker file. Here you can see this one is not a simple Docker file, it's a multi-stage Docker file. Let's first see the simple Docker file here in front end. Here is a simple Docker file. It's just like get Python 3.0, and then you'll say like what are the environmental variables, and then you're just going to run these applications. It's just simple, and you just have only one uh, from, and you're going to use this one. With this case, it's helpful if your application is having only very little data, and also like you don't have any intermediate files. But in Java, Java is typically not an interpreter language, it's a compiled language. So you are going to get a jar file, and then you're going to use the jar file to run in production. So what's happening in here is like I'm just creating the with this command clean package is going to give me a jar file. And then what I'm going to do is I don't need any other intermediate files that are generated by clean package or other commands. I just need the jar file to run in production. So next, what I'm going to do is like instead of using this big OpenJDK image, I'm going to use like smaller JDK image, which is like slim. If you say slim, it's like smaller version. And then I'm going to copy from build. If you see as keyword is mandatory, as keyword specifies like a replica of this one, like alias of something like this. So as build. So what I'm going to do is like copy from build. So it's going to copy from this intermediate container the jar file, and it's going to name as app.jar. And then we just have to run like java-jar app.jar. So it's going to repeat for all other programming languages. You can also do it for Go, Node.js, React, and also Python. For Python, there's something called wheel. So usually companies create wheel package and then they're going to use that wheel, import the wheel to other files. So that's this is like what a simple multi-stage Docker build looks like. So what I'm going to do is let's build this one. Docker build -t specifies tag, the image name, and then the latest. So always like latest is good, but specifying it as V1 or V2 or V3 or something like that uh definitely helps. So as you see, like here is like multiple stages of build that's going on. Uh let's wait for it. So here are some of the commands that are available in Docker. If you see Docker build is going to build, this one is going to build the image. BuildX is a superior version of build, which can build for multiple architectures, and there's like different commands like Docker images is going to list images in your local, and also Docker login is one of the other useful concepts. Like Docker login helps you log into your Docker hub or any other container registries that you have. I think like we have this application. I think we have this Docker image built. So let us run this stuff. If if you see here, it's like Docker run -p. -p specifies port forwarding. It's 8080. So what I'm saying is like 8080 port of a machine goes to 8080 port of the container that it is going to start. No, sure, I did not keep latest. I'm going to keep V1 and then I'm going to run it. So, okay, as we can see, the container is up. So as the container is up, let's check if this one is available. So let's go to zip account. So here is the external IP address. Let me go to the postman. I already have an API written, so let me change this one to the address. Let's check. See, uh, I sent like addition of two numbers. Number one is 2 and 3, and we got the response. Number one is 2, number 2 is 3. Operation is addition, and the result is 5. So, yep, that's how you run a container or an image. So that's what I said. In the meantime, like let's to exit from the container that's running, we can just say like Control C, which is going to exit from the container. Let's try to push the image that we build. Let's take Docker images. Here we can see like calculator backend V1 is available. Let's try to push this image to Docker Hub. Before that, let's log into Docker Hub. I already have an account on Docker Hub. So if you don't have an account on Docker Hub, let me show you. Okay, you can just sign up. You can use like Google Auth or GitHub Auth, which are simpler. But as I currently have an account, I'm going to just sign in. So what I'm going to do is like I'm going to log into my Docker Hub from the Docker CLI, Docker login, and I'm going to specify -u. It's Sharat24, and I need to specify password. You can give the same password that you try to log in into the Docker Hub, but there's a better way. We can go to my account, and then if we go to security, there's like this access token. What we can do is we can just like create a new access token, and then we can specify the name or the description of the class, and then we can just click create. Now we got this bad token. What we can do is like we can just paste it here and it logs in. So once we are logged in, we have an image with the name like this. But if you want to push to Docker Hub, you need to have it in a different pattern, which is you are going to have, let me show you. You are going to have your namespace and then the repository name. The repository name is nothing but the image name. Here, my namespace is Sharatchandra24, and the repository name is like calendar backend, which I already did, but that's how the pattern should be. What you can do for that one is you can always use Docker tag to tag an existing image with a different tag. So here is the example. I'm going to say like this one. As I already have V1 image published in my Docker Hub, if you see, there is already a V1 tag which is already present. So what I'm going to do is like instead of V1, I'm going to give it V2 or latest. Let me give latest. So this one is tag latest, and then on what I want, Docker push command is going to help you push to repository. As you can see, the exact repository ID is this one. This is very, very important because if you're using multiple registries like Docker registry or Docker Hub, also like Azure Container Registry or Elastic Container Registry from AWS, you will be having this one as a different one. So currently, like it's pushed here. So that's how you push an image that is built locally to Docker Hub. Now let's move on to our next part, which is using Docker Compose. First of all, let's analyze the Docker Compose file. Why do we need Docker Compose? Docker Compose helps us in deploying applications which are dependent on other. Like if you have an application stack, which is going to have front end, back end, and a database, or something like that. If you have two or three different services which are interlinked, but you are going to interact with the front end service and like the multiple backends, then Docker Compose helps us. If you see here, first one is Spring Boot app and then Python app. So these are services. Okay, and then now if you see like for the Spring Boot app, I specified image is this one and ports forwarding as this one. Network is clearly important if you're using multiple containers in a Docker Compose because this helps you interact between containers in the same network. For example, my Python application needs the host name of a Spring application. So I specified like Spring Boot app, which is the same name as it is here. So it internally Docker network can understand what is Spring Boot app and it can redirect requests to the specific service. So we just specify networks. So depends on tag. This is a tag which says like if you want this application to run in, then you obviously need Spring Boot app. That's what it's going to do. So if you're deploying like you can specifically run only single service in Docker Compose using Docker Compose up, and then you can specify Python app, but it's gonna say like, hey, if you want to run Python app, it says depends on Spring Boot app. So I'm gonna start Spring Boot app also. That's how it's gonna work. If you see here, I specified here image of image, sorry, the specific image. But here I did not specify image. I specified the location of Docker file. The context specifies location of the Docker file, and then Docker file specifies the name of the Docker file. Here I have Docker file with this name. If you see this Docker file, it's simple uh, Flask uh, Flask application on it, and then it does not have much more details. It just have like these things. But here I need environmental variables, which is like Spring hostname and Spring port. So I assign them in the environment. I specify these two stuff here. So now let's deploy this application, the front end application. Before going ahead and doing that, let's see if we have an application. So what I'm going to do is like I'm going to like system prune -a. So Docker system prune is going to remove all stop containers, networks, and also images and cache. That's it. But uh, I'm gonna do something more like I'm gonna say like Docker container ls, which is going to say like if there are any containers that are running. So every time, like if you want to see all, you can just pay, you can just type like -a at the end, and it's going to give you all. So Docker images is gonna look like there are 2 images. So, but I wanted to delete everything. So I'm gonna say like Docker system prune -a, which is going to remove all the things that Docker has. You can see like there's nothing image. So let's get one directory above. We have only MLOps calculator backend Spring. So let's clone this repo front end. And then let's go to this bit of front end. And then we're gonna say like Docker compose up hyphen build. If you see like Docker compose up is going to bring up the containers, but I'm specifying hyphen build because if you are running it multiple times, it's not going to build if you did not edit the files. So what we're going to do is like we can specify like hyphen build, so it knows like it needs to build every time. So I'm gonna say if you observe here, like in Docker Compose file, I specified the image name, which is in Docker registry. So it's going to pull this image because I don't have the image on my machine. So it is going to bring that image. It's going to download from Git, sorry, Docker Hub. So let's do this one. Docker Compose up. Uh, it specifies on okay. So another problem here. So the problem here it says like if you see your Docker Compose YAML, I specify version as 3.8, but it says like the 3.8 is not supported. You need to give like 2.2 or 3.3. So what I'm going to do is like I'm going to edit this file here. Nano is the editor that I wanted to use. Sorry, not I want to say let's edit Docker Compose file. I'm gonna say it's like 3.3. Okay, now what I'm gonna do is I'm gonna say like Docker Compose up hyphen build. You see, it's first going to create network, and then it's going to pull the image because it's not present. So it's going to pull from the registry, and then it's going to build the Python app. As far as I know, I think it should start Spring Boot app first, and then the Python app. Yep. Oh, Yep, it got up. Uh, if you see here, we are port forwarding 4500. So let's go to VMs. This is the IP address. Let's go 45000. Oh, okay. So hello world, but I have my application running in calculator. So yep, we are here. I'm gonna say like 2 and 3 iteration sum is 5. And say like 0 and division is going to return 0. So that's how you're going to use Docker Compose to run a container which is going to be an application of two containers. So I can, to exit from Docker Compose, we can just press Control C. It's going to kill, but here's a different thing. So I'm going to show you how to uh, run only. So now if you see, I specified like Docker Compose of Python app, but as you can see in our Docker YAML file, it says like depends on Spring Boot apps. It's going to bring up Spring Boot app too, but let's do it the other way. Mm, So we see Docker PS. I think calculator backend is already running. We can do like Docker can compose down, which is going to get done everything. Let's say the Docker PS. So now we don't have anything. The next step is like let's do like Docker compose as up, but this time I'm going to bring up only Spring Boot app. No, I think like it's going to bring only Spring Boot up. I think like it's attaching front end too, but I think if as it should not bring up here, so it's not going to get up because like it's not going to run the service. It's going to run only the backend, because backend is not dependent on front end, and only the front end is dependent. So we can just select Control C. Now let's see Docker PS or Docker container, Docker PS or Docker container LS. Both of them gives the same thing, but there are just like different short forms. And one other command which I would really highlight is commit. So if you make any changes to containers in runtime, if you want to create an image from the containers change, we can use commit. And Docker container CP is going to just copy files from one container to another container. Um, if you say like Docker create is going to create a new container. And I think like kill is going to stop. It's not stop, it's going to kill it like it's ungracefully, something like that. Docker pause is going to pause the container. Port is going to for port forward, or like it is going to list, and it's also used to port forward. Restart is going to restart it, and then RM is going to remove it. Let's see. Okay. I think like start is going to start, stop is going to stop container, unpause and everything. So let's see. Let's see if we can start container from some. Look, if you see here, there's a namespace right here. So I'm going to start from here. Docker container start. You see, I think like it's going to space return the same name. If you see, it's not running here. It says like exited. One foot about a minute ago. But if you check like Docker PS, it says running. It's forwarding up 11 seconds ago. That's how we can use Docker command here. Uh, this is the lab. for today. Um, y- let's check if I miss anything. The I think that's all. Thanks for